right, you three, let's get going. So today we're going to look at the next lesson in Unit 4, writing and solving systems using elimination. And we'll look at that in just a second. Just a couple announcements. We will be finishing Unit 4 soon, Wednesday next week, the 15th. Now, just a reminder, even if you're behind on Unit 2 or 3 or Unit 4, there's still time to finish Unit 4 on time, and I want you to at least do that. If we can't get all of it done by next week, at least try to finish Unit 4 with me, and then you can always go back and have Unit 2 and 3 or anything else you missed done later. It won't count for this month, but it will count when you finish it. So stick with me, and we those of you who were here yesterday and were participating all got credit. I think I put it in this morning for the first mastery test. So high five to you guys for doing that with me. Thank you for your trying. And today we're going to be doing the third mastery test. So there's still the second one to try on your own. So today we're going to do the third one. I want to show you how to do it and do some with you, and then hopefully stop with at least 20 minutes in the hour so we can do that like separately but together. And then if you have questions, I can do it with you. All right. Now, Savannah, you missed yesterday. So this really just applies to Levi and Anaya. But if you two don't mind, would you answer these questions for me in our Zoom chat, and you can send it directly to me. One, did you like doing the mastery test yesterday as a group? I guess that's like a yes or no. And then what would you change about how we did it? Anything at all? And I'm going to actually stop sharing my screen so I can look at your guys' responses and make it actually private. So Anaya, any changes that you would make to how we did that yesterday? And Levi, any changes? Anything you would have done differently or would have liked to see different if we ever do that again?
Good morning, teacher.
Hey, good morning, Victor. I appreciate the feedback. Anaya, if you don't mind, do you mean like not everyone has those questions on their mastery tests when you guys do it individually?
Yeah, because like that was it might have been another like the same mastery test, but maybe when it reopened it or you asked for it to be reopened. But that one yesterday, I didn't have that one. So I was like writing down like answers and things, but I didn't have that mastery test, so it kind of didn't apply to me. So it was just like work in my notebook.
I understand. Well, okay. I understand what you mean. My intention wasn't for you or anybody to have to go back and then redo it afterwards. I just wanted to. I was going to give you guys that score. Did I do that? Let me just double check. So, we did it as a group, and then we did those 5 questions together. And then anyone who was answering, or at least trying, you didn't even have to get them all right. I counted you guys, you folks, with that score. I think I made a mistake though when I did the grades this morning. So I'll have to fix that. Let me see what I did. Yeah, so let me change this. I meant to give you guys the actual score. So Levi, I'm going to update your score. And Anaya for that mastery test unit 1. All right, who else? And Victor. And Tira, but she's not here right now. Okay, so one more time, and I don't want to spend too much more time on this now, just because we got to get rolling on some math. But since I've got three other folks here now, Brooke, Anthony, and Victor, can you guys do this for me real quick? Answer these two questions in the Zoom chat and send it directly to me, or it can be to everyone if you don't mind. But if you don't want everyone to know, that's okay, and send it directly to me. Did you like doing the mastery test as a group yesterday? And that's okay if you didn't. I want to know how everyone felt. And then what would you change about how we did it, if anything? I want to get some feedback on what you guys thought about doing it that way. So you were all here, Brooke, Anthony, Victor. If I could get some feedback from you, I really appreciate it. I would love to know. Awesome. I see some responses coming in. And again, I'm going to stop sharing real quick so I can look at your responses privately. If you don't mind telling me what you did or didn't like about it, I really appreciate it. Like specifics. Just so that I can make changes, right, for the future. If I don't know, then I can't change it. All right. Well, thank you guys for telling me, and we'll do some math now.
I thought this might be too much to type in, but I wanted to let you know that the part that I liked the most about it was working on the problems together.
And for me, as a math doer, not just like the teacher, but a doer of math like you guys, I think the talking about it and the feedback and seeing what's right, what's wrong, that was a weird sound, is good, right? It's like that constant, immediate feedback um, instead of not knowing, kind of just like guessing, like I think I'm right, but I'm not sure. And then you get to the end and you got it wrong, and it's like, okay, well, I don't know what I did wrong. So thank you, Levi, for telling me.
Good morning.
All right, Philmon, good morning. All right, guys, let's get ready. So we're gonna start our actual new lesson today. So here we go. Okay, warm up question. Work on this with me. This will get us kind of prepped for the new material for systems with elimination. So assume with me that x is equal to 5. Simple little equation. Assume this is true. Now I want you to add 10 to both sides of this equation. So like this, if we added 10 on the left and on the right, we can simplify this a little bit. We can add together 5 plus 10, right? We know those numbers. So we can actually make that say equals 15. We don't, we do know what x is. We're assuming that it's 5. So we would say 10 plus x, okay? And then since we know that x is 5, I guess we could plug that in. But even without plugging in x is equal to 5 right here, without doing any substitution, my question to you is this: is x still equal to 5 right here? Or is it equal to something else? Is x still equal to 5 after we added 10 on both sides? After we manipulated it a little bit? If you can answer me in the chat, just your thoughts, what do you think? Or if you want, you can turn on your mic and tell me too. We started with this. We added 10 to both sides, which is supposed to be something we can do in math, right? You can do the same thing to both sides. So plus 10 plus 10. But then we end with this business, 10 plus x equals 15. And then the question is, does that affect or change that x equals to 5? So the x equal to 5 thing at the top, that's kind of like an assumption, right? We're just kind of setting it equal. Just like in all of our math problems, when you solve it and you get x is this number and y is this number, or a is this and b is this, whatever the letters are, the variables, we solve through the problem and we get some answer at the end, right? So I'm kind of starting with the answer, like saying x is equal to this number, and then we did something to it, added 10 to both sides. And you're right. It does look different, and it says it's equal to 15 now. However, it doesn't say x is equal to 15, does it? It's x plus 10. Do you see that? X plus 10. Assuming x is still 5, how we started. What happens if we made that x a 5 and added it? Does 10 plus 5, 10 plus x, does that jibe? Does that still equal 15? Like it should, right? Because x is 5. If x alone is 5, we add that to our 10, and now it says that should be equal to 15. Is that true? Does that seem like decent logic? You're right, those of you who said, no, it looks different now because, it says 10 plus x is 15. But that 10 plus x is different. We're adding it. So let's try it. We plug it in, 10 plus 5. I can substitute that in because x is equal to 5, right? 10 plus 5, 15, equal to 15. That seems true. We got a number equals itself. It's not like 10 is equal to 20 or 15 is equal to 100 or something pretty crazy. Something wrong, obviously wrong. So my my takeaway here is that even though it does change, like you all pointed out, when we added 10 to both sides, it does change what our equation looked like. Like, for instance, starting up at the top and then ending up down here with 10 plus x equals 15. Yes, it changes what it looks like for sure. However, because we did the same thing to both sides, let me show you one more way, and we'll come back. We had x is 5, and then we said add 10 to both sides. So let me do this. Let me write it a different way. 10 is equal to 10. And this seems a little redundant, so stick with me though. Imagine if we add the top equation to the bottom equation. Even though the bottom equation is kind of silly or kind of redundant, 10 is equal to 10. But imagine if we just add this top equation directly to the bottom. We get 10 plus x, and we get 5 plus 10, and we get this new third equation. We've changed what it looks like, but we haven't done anything wrong or like illegal math-wise because we've got two equations and we just added them together like a sandwich. And we combined like terms. Notice that. We can't combine 10 plus x because not like terms. However, we did combine 5 plus 10 because those are like terms, and it gave us the 15. We're going to do this with our systems of equations. We're going to add together the whole two equations to each other, but for a purpose. So today we're going to be solving systems using this process called elimination. Now remember, we talked about this weeks ago, the word eliminate, when I said like, can we rule out any of these options? Eliminate means, well, what does eliminate mean? You guys tell me. Can someone tell me either in the chat or verbally, what does eliminate mean to you? What does it sound like it means?
Get rid of.
get rid of. We're going to get rid of it. We're going to like remove it. We're going to make it go away, basically. Remove or make it go away, get rid of it. And so when we add or subtract one whole equation to the other, we're going to do that and eliminate one of the variables. So this means we'll eliminate one of the variables, either x or y. Okay, it could be either. It just depends on the whatever's best set up for in the equations they give us, by adding or subtracting one whole equation to the other. This is the theory or the idea behind elimination solving systems. Now, here's a quick other question before we look at an example. What is the solution? Let me write this down. What is the solution to a system of equations? We've been working on these all week. So in your own words, it doesn't have to match, exactly how I said it, but what does it mean to find the solution? Can anyone tell me your best guess, your best idea, explanation for the answer to a system of equations? Think back. Maybe I should ask a starting question before that. What is a system of equations? What does it mean to have a system of equations? Can anyone tell me?
I think it's probably the coordinates or the points. If like a graph were given.
Yeah. Levi for the win. Yes, the solution is the coordinate, the points of what? Has to do with two lines.
The x and y axis.
Yes, and it's of where the two lines are
intersecting.
Crossing or intersecting.
Crossing.
Yeah, absolutely. A system of equations is two equations. If we graph them, here's one of them, one function, one equation, graphed. Here's the other one. They meet somewhere at some coordinate, like Levi said, x comma y. The solution to the system of equations is that coordinate. So just a reminder, this is kind of where we're always heading when we're trying to find the solution to a system of equations. The solution is the point. That's the shorter word we use, but coordinate, right? Same thing. And then also the x and y. Thank you, Levi. So that's what we're looking for. So we're going to add or subtract a whole equation to the other one and get it to say x is a number. And then we'll have the x coordinate that we need. And then we can do it again and find the y coordinate that we need. So let's look at some examples. I am purposely starting with some of the word problem systems so that we can practice writing the equation first. Equations. So example 1, write the system of equations. That means write the two equations and then solve for the costs or solve for the x and the y. All right, here's our story problem. At the local market, Bill buys 3 juice boxes and 2 hot dogs at a cost of $8. Sarah buys 2 juice boxes and 1 hot dog at a cost of $5. And they want us to find the cost of the juice boxes and a cost of a hot dog. How much does one of each cost? Now, to start our system, we're going to group Bill's information and Sarah's information to write our two equations. 3 juice boxes. I'm going to not use X and Y. I'm going to use J for juice and H for hot dog. So 3 juice boxes plus 2 hot dogs is equal to $8. So there's Bill's equation. Sarah, 2 juice boxes and 1 hot dog is $5. So we've written the system. This is our system of equations. So we could graph these and look and see where they're meeting, where they're crossing or intersecting. But I want to do it algebraically using elimination. This is just another tool in the toolbox that you could use to solve for a system. The goal is, on Monday, we looked at graphing them and looking to see just visually where do they meet. So that's to solve a system by graphing. Then on Tuesday and yesterday, we did work with substitution. So plugging one equation into the other, substituting one of these equations into the other. And today we're going to try eliminating one from the other. And the goal is to eliminate the H's or to eliminate the J's. Now, here's the deal. I want to just be able to add together the top to the bottom equation and make my H's go away or my J's go away. But if I do that, let's try just adding them together and see what happens. I'm going to add the whole top equation to that whole bottom equation. So 3J's plus 2J's is how many J's? If I added just the J's up, anybody?
5J.
5J's. Do the H's for me. 2 H's plus 1 H. How many H's?
3.
Good, both of you. And then the whole numbers, obviously, they can add their like terms. 8 plus 5 gives us 13. So we just made this new equation. This is a legitimate equation we just found. The problem is we didn't eliminate anything. Didn't eliminate J or H. Sad face. So we have to do a little bit of manipulation to one of our equations to make the J's or the H's match. We want to make them each have 2H or each have 3J or 6J or something. So we're going to have to manipulate or change. Manipulate's a big word to write. Manipulate. Or change one of these equations to make it match the other. All right, I'm going to draw a line here, and we'll do that on the right side. All right, we'll go back to red. So look at the red equations at the beginning with me. We tried adding them together in purple, but that didn't work. It didn't eliminate J or H. Looking at the original red equations again, is there any number that you can multiply to? Let's look at the bottom equation. 2J plus 1H equals 5. Is there any number that you see that you can multiply to all those numbers, 2, 1, and 5, that would make it match up with either 3J or 2H or 8 at the top? I'm looking at the H's specifically. Is there anything I can multiply to that 1H to make it match up with the 2H above?
Two.
Nice. That was Anaya? Thank you. So we have to visually inspect and ask ourselves, is there anything I can multiply to one of these equations to make it match the other one? And Anaya got it. It's 2. Here's what we're going to do. I'm going to take my 2J plus 1H plus equals 5 and imagine multiplying multiply the whole equation, left and right side, multiply the equation by 2. So that's going to be 2 times 2j plus 2 times h, 1h, equals 2 times 5. It's literally like doubling the equation. You're doubling the left and you're doubling the right. What are we left with now that we've changed and manipulated it? We've got 4j plus 2h equals 10. We took the original, we scaled it up by a factor of 2, and that's okay because we did it to both sides. Now, let's take our 3j plus 2h equals 8 equation. So back to the beginning, I'm looking at my originals. I changed one of them. Let's take the other original, 3j. I'm going to put that below like this. And now we're happy because the h's match. We didn't make both j and h match. We won't ever be able to do that. It'll probably just be one or the other. But since these match, now we can subtract. I'm going to write it out the same way we like write out subtraction in the old days. Back when you first learned about it, you put one on top of the other and do minus. And we're going to go down the line and do 4j minus 3j, 2h minus 2h, and 10 minus 8. So let's do that now. 4j's take away 3j's gives us a single 1j left over. 2h minus 2h is 0. We've canceled them basically. And 10 minus 8 is 2. Now, you don't have to show that plus 0, but I wanted to keep it in so you could see what each result is. So what do we have when we simplify this? J is equal to 2. So we just found one of our costs. Juice boxes are $2 each. And if we were using X and Y like normal, then J would be X, H would be Y, and that means we just solved for X. The other variable, one of the variables is 2 basically. The J is 2. So to find H, we actually do the same thing we do with substitution. Now that we found one of these numbers, J is 2, we're going to plug that into either of our starting equations. So just continuing on the right, forgive me, I know there's not a lot of space. We can pick either equation, and it's best to pick the one with the smaller looking numbers. Always go for the easier looking equation, smaller numbers or less negatives maybe. So I'm going to take 2j plus 1h, and remember, we can just write it as straight up h. I've just been keeping the 1 there to show, emphasize that we have only one, equals 5. So now I'm going to substitute or plug in that 2 for j. So 2 times j is 2 times 2 plus h equals 5. And simplify this. Do the multiplication. 2 times 2 is 4. Minus 4 from both sides. Okay. So minus 4, and we get h is 1. And we just solved the system using elimination. So j is 2, h is 1. And if we were doing this at Inventum, looking back at the top, the cost of each juice box is $2. The cost of each hot dog is $1. So in the middle of the screen, what we first started with, we don't have to always start by adding them together like I did. I wanted to just show you that that's our goal. We want to be able to either add or subtract them and make the H's or the J's eliminate. But since it didn't work, our step 1 is going to be make one of them match the other, like we did in red. And when you add them or subtract them, after you've made one equation match the other's coefficients, the number next to the j or the h, you eliminate it like we did here. We got 2h minus 2h, and we end up with 0, right? We made it go away and found j is 2. Okay, I'm going to wait just a few moments in case people are writing, and if you need more time, just let me know. But then we're going to look at another example where we are given the equations from the beginning. So not a word problem, just like a straight systems problem. Okay, let's try another one. Example 2. Solve the system of equations. So let's examine this thing together before we start. 2x plus 8y is equal to 5. 24x minus 4y is equal to negative 15. So our line of thinking is, do any of the coefficients match? No, they don't right now. We've got 2x and 24x. Those don't match. We've got 8y and negative 4y, and those don't match either. Now, my next question is, can we multiply any number to the smaller looking equation to make either the x's or the y's match? Like we did last time. Last time we had to multiply one of the equations by 2. Is there any number you can multiply on the top equation to make it kind of match up with the bottom coefficient, one of the bottom coefficients? Any thoughts?
You can multiply. Oh, yeah, you can multiply 2 to get 4.
So the top one, multiply the top equation by 2?
Yeah.
Totally. Let's try that out. If we hit everything with a 2, like this, times 2, times 2, times 2, this is the right idea. And this, Levi said it makes a 4. You're right. 4x, 2 times 8y, that'd be plus 16y. And then 2 times 5, 10. So a legal move, totally good. Double check what we have. Remember, our mini goal here is that we want the y's to be the same number or the x's to be the same number. Now, I like this approach of try multiplying it by, try your first thought. Try the first number we can, because we're going to have to manipulate or change one of these equations probably every time, just like we have been. If they don't match still, then we're going to try another one until they do match. So we want it to be like 24x, 24x, or 4y, 4y, or 16y, 16y, something like that. There's honestly more than one way we could do it. So there's not one right way to do this here. I'm going to put it here. Let's start. I'm going to make a line here. I'm going to rewrite our starting equations. So equation, the top equation and bottom equation. I'm going to take what Levi said. I'm going to try doing, instead of the top equation, let's try doing the bottom. Why would I want to do that? Because we'll get a 24 times 2, that gets even bigger. That turns into 48x. Doesn't match. But look at the y's. our 4y, or really it's negative 4y, that'll turn into negative 8y. And then we've got a match of numbers, 8 and 8. So here's let's try that. Let's take what Levi did. We're going to multiply it to the bottom. And forgive me, maybe that's what you meant. I just twisted it around. Let's multiply 2 to the bottom equation this time. I'm going to move over the top one to here. Okay, and now we're going to multiply a 2 to everything on the bottom. So 2 times 24, 2 times 4, and 2 times negative 15. So we get 48x negative 8y, and then 2 times 15, negative 30. Negative 30. And now we're ready to rock and roll because we've got 8y, negative 8y. So we're going to add or subtract the two equations together. So here's another thought process we've got to go through. Do we want to add them or do we want to subtract them? If we add them together the way they are, then we've got a positive 8 on top and a negative 8 below, and that's going to be the key to doing the elimination. Last time we subtracted. This time we're going to add the two equations because we've already got a positive 8 here and a negative 8, and those will cancel. So 2x plus 48x, 2 plus 48, 50x. 8y plus a negative 8y, those cancel out. And then 5 plus negative 30, negative 25. So now we have this. I'm going to write it again a little cleaner. We've got 50x equals negative 25. Who can help me out with this one? What's our last step to get x alone? Should I subtract 50 both sides? Should I divide 50 both sides? Divide 50 both sides. So we get x is equal to negative 25 over 50. Kind of scary looking fraction. Try reducing it. You can divide each of those by 5, or you could actually divide each of those by 25. And this is going to be negative a half. So x is negative a half. Okay, so we did get a fraction answer, but that doesn't mean we did it wrong. It's just that means that x is negative a half in this system where they're crossing. Okay, so since we got one of the variables, now we're going to start over. We're going to take our answer of negative a half for x, plug it into the easier looking equation. I think the easier one would be 2x 8y equals 5 because they're smaller overall than 24 and 15. So now start with the original. Plug in negative a half for x. Okay, 2 times a half, 2 times 1 on top. So we've got like negative 2 over 2, negative 1, plus 8y equals 5. Solving the mini equation, we've got to add 1 to both sides. I'm going to move over here to finish. So add 1 to both sides. 8y is equal to 6. Like last time, Anaya said divide. We're going to divide both sides by 8. So we have y is equal to, y is equal to 6/8. And as always, I want you to reduce your fractions when possible. Rats. So looks like we could divide top and bottom by 2, making it 3/4. All right, so at the very tip top of the screen, let's show our answer as a point solution. is negative a half, comma, 3/4. And hey, you know what? Earlier this week, I was showing you guys Desmos. Really quick, let's check this out. I want to take our two equations. We're going to plug both those equations into Desmos and see if it looks like their crossing point is what we just found, negative a half up 3/4. So let's try that. It's 2x plus 8y equals 5, and 24x minus 4y equals negative 15. We'll come right back and do another example. Okay, Desmos. So remember, if you're going to use Desmos, you just type your equation into the left side. It doesn't have to be in slope-intercept form. We're going to type it in just like it is in the problem. 2x plus 8y equals 5. So there's the first line from our system. 24x minus 4y equals negative 15. Boom. So there's the two lines. The blue one is the second, and we zoom this guy in. And if you click on it, look at that. Negative 0.5, that's negative a half. Positive 0.75, which is the same thing as 3/4. If you try the division, you get 0.75. So you can use Desmos to kind of check your work. I suppose you could have just plugged those into Desmos to start with and found this, but Inventum might have the answer in fraction form, right? Maybe it'll be in decimal, maybe it'll be in fraction. So I think it's a good tool to use to check your work. All right, we've got 15 minutes left. I don't think we're going to have time to, let's talk real quick. I've got a couple more examples ready to go. Would you guys, let's do a vote. Let's make this democratic. The most votes wins. Do you want to stop now and start doing the mastery test with time to do it together and ask questions?